So let's try this composition on point A, 3, -2. So 3, -2, we know how to graph. That's not an issue. All right, everyone sees the composition symbol right there. So you're going to do two transformations right now, a translation and a rotation. Which one do I do first? The translation. Why? Because I perform these right to left. So I'm going to take point A first and translate it -2, 4. -2, 4. So where you guys just took the quiz yesterday, where am I going to move point A? -2, 4. What direction and distance? 4?
Left 2, up 4.
So everyone go ahead. Go left 2, up 4. Left 2, 1, 2, 3, 4. So I'm right here now. And again, I'm not going to call this point anything because I'm not done yet. I'm not done. All right. I'm going to call my final point A prime, but I'm not done yet. Now I take this point, keep going to the left, and now I'm going to take the point where I am and rotate it 90. Which direction? Going off of yesterday's quiz, 90 degrees. Which direction am I rotating? One, Anna? Counterclockwise. So everyone right now is looking at your paper. Either you memorize the rules and can do it without turning, or all of us right now are going to turn it 1/4 turn to the left. All right, go ahead, turn it 1/4 turn to the left. And where do I end up with my final point here? A prime, 1/4 turn to the left. 11, 1, Anna, back to you.
-2, 1.
-2, +1, good job. So that's what a composition is. It's just multiple transformations done at the same time. All right, instead of doing, all right, part A, do a translation, part B, do a rotation. We do it all at once with that symbol. Look good? Any issues there? So 2 or more transformations at the same time. That's what we're doing, 2 or more. All right, let's do it on an actual figure now. What do you say? We got triangle text. Let's graph it. -5, 2 is T. -1, 3. And everyone sees the composition I'm asking you to do right up here. Here's the composition I'm asking you to perform. All right, I have a translation and a reflection going on. Which one should we do first on T, E, and X? Which one? 6? Reflection over the y-axis. So go ahead, everyone, take triangle text, reflect it over the y-axis. Again, I don't name these points because I'm not done with the transformation yet. 1, 2, 1, 2, got it. 1, 1, 1, 2, 3, 1, 2, 3. There it is. I'm embarrassed. I'm not even going to say anything. Hopefully nobody noticed that. There we go. And then finally, what am I doing next now? Taking those points and keep going to the left of my composition. Keep going to the left. 12 from here.
You go down 5.
That's it. No right or left because I put a 0 there. Good, Rachel. Good. I don't go right or left. I just go down 5 with those points. And then now I have T prime, E prime, and X prime. the directions do say graph, which we did, and state. So let's state the coordinates now. T prime, E prime, X prime. Uh, 10 when you're ready. Those coordinates.
T prime is 5, -3.
Yes.
E prime is 1, -2.
Yep.
And X prime is 2, -4.
There you go. Great work. Great work. Everyone else, all right? All right, a little field trip now. We have a special type of composition, all right, that I want you to be aware of. And for me to talk about it or to show you or just to write it in your packet is not good enough. All right, we actually need to perform it ourselves. All right, so we're going to go out in the hallway right now, a little quick field trip, and show you this new composition. Take a look at the name right down at the bottom of your packet, a glide reflection. All right, a glide reflection. It is a special type of composition. Okay, so that was a glide. That's a special type of composition, glide reflection. All right, so instead of reading that all to you, I wanted to see it. All right, so reflect, translate, a reflection on a line parallel to it. All right, here we go. Let's move on. Okay, I'm going to get some new vocab terms now. New vocab terms. First one, orientation. Orientation, ready? That's the direction of a figure's vertices. Direction of a figure's vertices, and we'll give you an example here. Triangle DEF. Direction of its vertices. So if I go from D to E, E to F, F to D, that's in what type of direction? Think about your rotations. What direction did I go in? Clockwise or counterclockwise? What am I going here from D to E to F? So we say this triangle has clockwise orientation. All right, this triangle would have clockwise orientation. That's what I mean by orientation, the direction of the vertices. Direction of its vertices. So I'm going to leave that up there. Ooh, here's this term again. Rigid motions. Rigid motions. Does not change size or shape of the figure. Guys, we've gone over 3 of them already. What are the 3 rigid motions we've already gone over? You've been quizzed on them as well. 3 transformations that do not change size or shape of a figure. What do you have? One and one of them. Okay, so we've done a translation. I'm not going to write any down yet. We've also done a 11 rotation, and then what was the third one we've done that does not change size or shape? 2. Rotation, translation, and first one we did. Reflection. Those are the 3 we've done. Everyone agree? All right, here's what I'm going to challenge you with now. Out of those 3, let me write them down. Actually, let me just symbolize them. Reflection, rotation, translation. Out of those 3 rigid motions, which one do you think would keep the orientation the same? So right now on triangle DEF, these vertices are going clockwise. Which one of these 3, if I perform them, the vertices would still be going clockwise? That's what I want you to think about. Think about which one of these 3 rigid motions would keep the orientation the same. A reflection, a rotation, translation. Which one of the 3 would keep the orientation clockwise still? 12? Hey, look, turn the figure. Is it still going DEF in a clockwise rotation? Great job. So rotations do not change orientation. Ooh, but I have a number 2 here, though. There must be a second one that won't change it. Rotations, it'll still go clockwise. And what else, if I performed it on it, would still go clockwise? 8? That's what all these are. This is everyone gets them, so everyone gets them confused every year. Translation is a type of transformation, yes. So translation, good. Those 2 will not change orientation. Everyone see why? Slide a figure. It's still going to go DEF clockwise. opposite orientation now. So now I'm going to perform it, and now it's going to go counterclockwise DEF. So what could I do to a figure where now the order of the letters goes opposite of where it started from? And I know process of elimination, what are you just going to tell me? Reflection, right? You flip a figure over. Reflection. Or did you just look on my paper? My notes here? Yeah. Okay. Yeah. And there's one more. What did we just talk about outside? Glide. Why would a glide reflection change the order? Because you still have to do what? Great. Yes. You still have to reflect. So a glide reflection would also have opposite orientation. So we all get on what I mean by opposite orientation versus same. Same orientation, it goes clockwise, clockwise, clockwise. Opposite, one goes clockwise, and then the next one would go counterclockwise. All good? Because because I'm going to, this is kind of like a two-part day today. I'm going on to the second part right now. Orientation, why they stay the same for rotation and translation versus reflection and glide reflection. We're all good? All right. Let's go to the second half of today. Here's where I need you to be for Monday anyway. I'm going to give you a figure, and I'm going to give you its image. And I want you guys to come up with, how did I get there? In 2 or more transformations. One won't cut it. Okay? If I want to go from A, B, C, D, E to the single prime one, it's not going to be done in one transformation. It's going to be done in 2 transformations. So I've given you multiple choice right now to see, and this is, I don't want to say too much because still got people who need to take the quiz, but this is similar to what one of the questions on the quiz yesterday, if you remember or not. All right, so take a look at my choices now. How can I match up A, B, C, D, E onto the double prime one? I've given you choices and only one will do it. So do I have to rotate 90 and then reflect over the X, rotate 90 and then go down 7? Can I do a reflection over the Y, then the X? So here's what I would do, right? Hey, everyone. Here's how I would just ask you guys to approach this. Pick a point. So let's start with point A. After I do one of these, do I end up at A double prime? And just to be on the safe side, I'd pick a second point and do the same thing and make sure I land on B double prime. All right, I wouldn't do the whole figure. Just take a point and do it. All right, so go ahead, go through it. I don't want to give stuff away here. And if it doesn't work for one point, don't even bother doing a second point. Just go on to the next choice. I'm pretty confident we could get rid of number 3 right away without even testing a point. Everyone see why? Take a look. Just forget about the actual coordinates. Look at A, B, C, D, E to the double prime one. Hasn't it been turned? All right, so number 3 doesn't even involve a rotation. And you think about it, if I reflect it over the Y and then I reflect it over the X, it's still pointing in one way or the other, not up and down. All right, it's still pointing left and right. So there's got to be a rotation here somewhere. Has to be. We figure it out? Which one it's going to be? What's the agreement here? Choice 2. Yep. You had to rotate at 90 and then go down 7. Yep, rotate it 90, down 7. This is where we're going with this now. And you're not going to like what's coming up here at the end of today. You're not going to like it. All right, let's go 2 now. Same thing. How do I move ABC onto RST? Hey, remember, hey, notice A's got to match up with what, everyone? A's got to match up with R, yeah. B to S, C to T. Remember that. Keep that in mind. Keep that in mind that A and R have to match up, B and S are the match up, and C and T. All right, align reflection over Y equals X. Well, we know what's that rule from yesterday's quiz? If you reflect over Y equals X, the coordinates should do what? 8. You remember, Sophia? The coordinates should flip, right? Flips. All right. So let's take it. Let's take point C right now. Point C is 2. What's that? -1, 2. So point T, what it matches up with, should be 2, -1. Anybody? Is anything at 2, -1? Is anything graphed at 2, -1? Nope. So it can't be a line reflection through Y equals X. Definitely not. All right, let's keep moving. A rotational 180, but now centered at 1, 0. Find 1, 0, everyone. 1, 0. We're going to rotate around that point right there. 1, 0, 180. To you, I don't know to you, to me, 180, other side, right? 180. When I rotate 180, it's on the other side. And I know some of you, hey, and this is a good point here. I know some of you guys want to start turning your paper. The paper turn trick method only works when we rotate around the center. All right, 0, 0. All right, around the origin. So I can't turn my paper here. But look, somebody remind me again, what should T match up with here? Point T should match up with which point? Point C, right? And if I look through, if I go on the opposite side of 1, 0, what's on the opposite side? Point C. Everyone see? Yes? Okay. What should R match up with? Point R should match up with A. Take a look. R, A. 180 degrees. Are they on the opposite side of each other? Yeah. They form a straight line going through. All right. So that's why it's going to be a rotational 180 through here. And look, let's say, okay, you're not fully sold on that choice. Do the other 2 choices, and you're going to find that they don't match up either. All right. Maybe you're not sold on choice 2. But if you go through 3 and 4, nope, not going to happen either. All right? Questions? All right, this is the part you might struggle with now. No more multiple choice. You guys have to come up with the sequence of transformations that happen. Okay? No more multiple choice to check. You have to come up with your own method. And there's probably will be multiple methods here that work. All right, so talk it through with each other, by yourself. How am I going to get trapezoid ABCD onto the double prime one? And guys, you can make as many moves as you want. I prefer maybe 2 or 3 tops, but you can make as many moves as you need to make sure that A has to go to A double prime. B has to go to B double prime. And it's just not a flip, right? It's just not a flip over the x-axis. They won't match up that way. It's just not a flip. So I have to do this first, and then this for A and A double prime, B to B double prime. This is tough. Finding your own rules now. Okay, here's a starting point. Because I know kids really, they don't know where to start. They just start throwing stuff out. Is there a turn here? Look, is there going to be a turn? Because here's D and here's D double prime. Is there going to be a turn somehow, maybe? To get there? Yeah. So what's got to be involved in your sequence of transformations, eh? Rotation, yeah. All right. Probably I'm not going to say, I won't say anything else, but probably a rotation here. Go ahead.
Could you reflect over the y-axis and change the A from this this side to that side?
You can do anything you want. You can do anything you want. As long as A matches up with A double prime at the end of your sequence. And let me know the order you want to do it too. Just don't say rotation. Hey, just don't say rotation, a rotation of how many degrees, right? Don't just say translation. Translation up, down, how many? Just don't say reflection. Tell me what line to reflect over. All right, so just don't give me the words. Tell me something else with them. I have one written down on my paper, but there could be multiple ways. Just make sure all 4 points match up where they should. Two or more. Preferably stop at 3, but if you need more than 3, go ahead. We need this skill on Monday. Anybody want to throw theirs out? Confident, Nate Dog?
Yeah.
Okay, go ahead.
Rotation 180.
Is that the first thing you're doing?
Yeah.
Okay, so rotation. And notice I like how he gave me a degree measure. Just don't leave it rotation. Rotation of 180 degrees. Followed by, because that's not, right? Just that alone won't cut it. Then where you got to go?
A translation down 2.
Then followed by a translation down 2.
Yeah.
That's what I had on mine. Great minds think alike. Anybody else got another one they want? Anna, go ahead.
Reflect over the y-axis and then reflect over y equals -1.
Okay, so let me just pick a point here and try that. I just want to make sure because I didn't have. So reflect over the y-axis, right? Okay, so I go here and then reflect where?
Y equals -1.
Which would be this line right here. 1, 2, 3. 1, 2. I like it. Works for me. Good job. Perfect example. You're gonna give me a third one?
Sure.
Oh boy.
Reflecting over the y-axis.
Okay, stop. All right, I just did that here. Yep. And then where?
Reflecting over the x-axis.
1, 2, 1, 2. Yep.
And then a translation of -0, -2.
Down 2. All right, I like it. Did it in 3. Boss move there. Nice. So you guys see? Multiple ways to do it. All right. Now also too, if you guys want to do symbolically, I wrote it out, but if you want to do it symbolically, like R180, T0 -2, or hey, you want to be really nuts? Really nuts? Introduce the composition we did today. So rotational 180 out to the right, keep going to the left, translation, down 2 if you want to get nuts. Just make sure whatever you're doing first is on the furthest to the right. Yeah, stud.
Are we able to use like rotation of 180 centered at like?
You don't need to do the centered stuff. I'm assuming it's at 0, 0. Yeah. Just tell me, all I need is degree measure. All right. If you don't write the word rotation. Tell me how many degrees. All right. One doesn't make you great, right? Come on. I got another one here for you. Get A, B, C to D, E, F. Describe a sequence of rigid motions, translations, rotations. Remember, A's got to match up with D, B to E, C to F. Ah, you guys are talking today. I like it. Maybe before I forget, Coach Rounds was in here earlier. You got to see him at some point today.
Okay.
Nice to see you. What do you think? Anybody got it in? I don't like calling numbers here. What do you got for me?
Reflection over y equals 2, and then reflection over y-axis.
Okay, so let's test that out on A. So you said y equals 2 first, right? Okay, so that's that horizontal line. So A would go right here, and then where?
Reflection over the y-axis.
1, 2, 3, 1, 2, 3. That would match up with D, and A's got to match up with D. All right, so we got a reflection over y equals 2, followed by a reflection over the y-axis. I like it. And I believe you could also go in reverse too. If anybody did reflection over the y, then y equals 2, that works as well. If we did it the opposite direction here, it would work. Anything else you want to throw out there? Okay, this isn't, I wish it was, it was just a one-timer thing, but we need to be able to do this, go from one to the other in our own words, going to Monday. All right, because now the next step is show me they're congruent now without doing a statements reasons proof. All right, that's where we're going Monday. All right, guys, go ahead. Get going on. Great job today. Great job. Little hallway field trip. People were talking.